Hi everyone, today we're looking at Chapter 1, Section 1, or the Key Issue 1 of Rubensteinds text. How do geographers describe where things are? This seems like a pretty straightforward statement, but maps, pretty important in geography. But hopefully through this course we're going to be looking more at the spatial relationships, not just identifying where things are. And through history, maps have served lots of different purposes, but they have a common theme, both as serve as reference tools and tools to communicate specific information. And so whether we're looking at a map from ancient Babylon that you see on the clay tablet there, dating back to 600 BCE, or the stick map of the Marshall Islands dating back to the 300 CE, or the map from China in this lower right corner represents the 15th century, all serve sort of a pattern or serve important information that is not meant to be preserved, shared, and communicated to others. As we look at all maps, they provide some sort of information, and if it's a well-organized map, you're going to see a lot of these common themes throughout. In fact, there's an acronym, TOTALS, that you've probably come across before. Title, orientation, date, author, legend, scale, and sometimes we talk about indexes or grids, or the source itself. But a good map is going to have most, if not all, of these things to provide the best information that makes it useful to its user. In terms of scale, maps are projections. They are of the Earth's surface. They are obviously not meant to be full scale. But one thing to understand about scale is that it's a relative size, and it's actually counterintuitive. When we talk about a large-scale map, we're actually talking about a representation of a much smaller area on the Earth's surface. We do this so we have less distortion and a more accurate view of a particular place or area. And we see this with maps like cities, where we see ratios where you're going to see 1 to 100,000, greater ratios of 1 to 100,000, where you're going to see for every inch on the map, or every unit represented on the map, inch, centimeter, mile, whatever, it represents 100,000 of those on the particular map itself. And so when we look at this, we're looking at a very specific place like here in New Orleans after Katrina, we want to see representations on a large scale to provide useful information to us. When we talk about a small scale map, we're actually talking about a much bigger area on the Earth's surface. And so when we start talking about small scale, we're looking at ratios of less than 1 to 1 million. And so this is where you're going to see the much bigger in terms of representations of the Earth's surface, but it's considered a small scale map. Large areas, and also with the more area we show, the more distortion we're going to have, because again, we're taking a three-dimensional object and turning it into a two-dimensional projection. So, as a quick way of making practice of the idea of scale, obviously you can pause it if you need to or go back, but just take a look at these four maps. They all represent an urban area that appears to be very similar in size and shape. However, if we look at the scale, we can see they're very different. In fact, two of these are large scale and two of them are small scale. So pause it for a second and see which ones are large and small. Looking at this, you would determine that the scales represented, that the top A and B are large scale and C and D are small scale, based on those definitions we provided before. And when we represent scale, it doesn't have to be in terms of a ratio. In fact, you saw the graphic bar scale on those previous maps that represent, a certain distance represents the equivalent on the Earth's surface, or it could be a written statement, or it could be represented in terms of the fraction or ratio that we defined scale by. Besides the scale piece of a map, maps are huge. Another important use was into determining how land or space is being utilized. In the United States, something called the U.S. Land Ordinance of 1785 was a huge determining factor in how land was developed in townships and cities, and the West was defined because of the work of Thomas Hutchins. Basically, when the U.S. started moving west, the township and range system was put in place. There were principal meridians and baselines that were used to create essentially a massive grid across the continent, and or across the country, and were used to determine where towns were. And these townships were divided into 6 by 6, or 1 mile, 6 by 6 miles, and within that had a subdivision within that, and were divided into 36 sections. And then within that, they were quartered, or that they represented 160 acres. If we look locally, this is just taking a layer of onto a satellite image from Google Earth, and is the representation of the township and range system as it applies locally. So you can see the township that's represented where Mounds View is, and Arden Hills, and much of Shoreview is the T30 North and the R23 West, and it's the township and range based on relative meridians and baselines that give us coordinates of a particular area, and within that the subdivisions that you see within. However, if we talk about this and look at, you can see this, I'm sorry, this is another representation that you can see those subdivisions. But this Hutchins Township and Range System and the Ordinance of 1785 is not the only way land was divided. That's just how we did it here in the United States. There's other examples of this, and on a local, more localized perspective, you see this even around Turtle Lake. If you look at Tanglewood and go to Google Earth and look at the lots divided up around Turtle Lake, you see this. But the French long lot are long strips extending to like a waterway or a road, and this is something that is often obviously where there's necessary access to a particular resource, whether again an avenue or a node of transportation, or access to something very important to the local area. Another way of dividing land is through the meets and bounds system, basically taking reference points on the physical landscape and creating boundaries or plots of land based on those natural boundaries. Hopefully that gives you a quick summary of what maps and the purpose of maps are, and just how maps can be used for locational purposes. In the next video, we'll look a little bit more closely at map projections.